Welcome to Is AL Your Type? Hey, I'm Eric, and in this video we're going to talk about types. And you might ask, but hang on, what is types? And types are the different, whenever you have a variable in AL, it has to have a type. It can be a text, it can be a decimal, it can be an integer, it can be a date, it can be a lot of things. All those are types. And in the world of computers, the world of languages, programming languages, we kind of have two major groups. We have languages that at compile time decides what everything is, what type is something, and we have languages that at runtime tries to figure out what the type of stuff is. And the reason for all this is that when it comes down to it, the computer itself, most computers, should I say, does not care about the type of something. It holds whatever you create a variable, that variable will eventually end up in memory. And the computer doesn't really care about what's in memory. So let me show you. So here is it's actually the main board from one of the first IBM computers. There's the IBM PC, and you can see here in this case, this motherboard has 3 banks of chips, and you see there are 8 chips together because it happens to be an 8-bit computer. In reality, the first PC was 8-bit, even though the CPU was 20-bit, and anyway, the memory address space was 20 bits, but that's a whole other story. But so if I were to store the letter A, which is decimal 65, I would store it in here. But actually that 65 is 8 bits. So the bit 0 in this one, and bit 1 in this one, and 2 and 4 and 8 and so on. The bits are spawned across these 8 chips. So each of these chips might be 64K, but 64K of 1 bit. So it takes 8 chips to get 64K of bytes, if that makes any sense. So just as an example that the computer, everything is just memory. Were a few computers built for very specific purposes, military, I think, that actually had hardware typing. So the hardware knew what was the content of memory and what the type was in order to harden to prevent errors and so on. That didn't really catch on in other than very specialized systems. And what we have today with a PC is the PC just has general memory. So it's up to somebody else to determine what's in the memory. And this also goes for AL. So if we take a piece of AL like this one, and we create a variable here, and we create an integer, and we create 2 more. So now we have 3 integers. So an integer there in AL sense is a 32-bit value. So from -2 billion to approximately to plus 2 billions. Those are the 4 billion you can have in a 32 integer variable. So these will take up 4 bytes. 32 bits be 4 bytes. So 4 times 3 is 12 bytes. So at some point in time, when the computer is running this program, it will allocate 12 bytes on the stack, and say, okay, these 12 bytes, and then the compiler knows that there are 12 bytes set aside, and in the first 4 bytes we have I, and the next 4 we have I2 and I3. If you ever heard about buffer overruns, like errors that were, somebody found a vulnerability where you could create a buffer overrun. That would basically mean that you could somehow, get the program to access memory outside of the 12 and then thereby corrupt some other memory, but corrupt it in a very specific way. So you corrupt the memory that holds the program, so you can get it to execute some invalid code. That's not what we're doing in this thing. So in case of AL here, it's the compiler that knows the type. If you have something else, so if we go to, here is a web browser. So if we open the JavaScript console here, and I could set a equal 2. That's great. Then I could say a equal hello. No, so clearly 2 and hello is not the same thing. I could clear a function called add that takes 2 parameters and returns a plus b. So if we go and say add 2 and 3, we'll get 5. If we say add Eric and YouTube, we will get a string that holds both things. So in this case, JavaScript is not a strongly typed system. So in case of JavaScript, the memory structure is very, very different from this, because whenever we store something, whenever JavaScript stores something in memory, it also stores information about the type, the size, and all that good stuff. So in case of this function that takes 2 variables, and as long as we can, so the compiler, or when we load this piece of JavaScript, will never say that this code has an error. But if somewhere you would run it and say 2 and 3 and Eric, then JavaScript is way more complicated, because now it says but we'll just treat the 3 as a string. But what if we pass 3 and null? Then we'll get a 3. What if we pass the other way around, Eric and something? What about if it's a decimal? So JavaScript is weird, right? So it changes the type on you depending on what you happen to pass into it. Or what if we add an object? Well, now we get a string where it says Eric and then an object here. I think that's a way to get this to really get mad at us. But it's really hard, because it's just very, very happy. Of course, we could change the function to, if we do mult and then return a times b here. Now we have a mult function, so we can do mult there. We can also do mult with decimals. Mult 34 and Eric. No, that doesn't work. But we don't get this error until we hit runtime. So JavaScript is a dynamically typed language, which is the reason why TypeScript was ever invented. No, not the only reason, but one of the reasons that you could have TypeScript is typed JavaScript. So this would never be allowed in JavaScript or in TypeScript, but it's allowed in JavaScript. Anyway, let's get back to AL and see what is actually allowed in here. So I will get rid of this one, and I think before I started the video I created a function down here. Oh, it was just the on-open page. I added some variables. And what can we do? So we can easily do, let me just read the ones I created, just to have some. I got a text, I got a code, I got an integer, a decimal, 2 dates, time and date time, a duration, and a big text. So I could do text equal code. I think that's fine. I didn't get any errors here. I could do code equal text. Can I do text equal big text? Oh, sorry. I think I call that, let's call it BT. So I'm crying out. No. Cannot implicitly convert type big text to text. Can I do the other one around? Big text equal text? No, I cannot do that either. So there's no shortcuts here. Let's try with integers. So I can do integer equal decimal, no problem. I can do decimal equal integer. That's fine. What if I do decimal times 1.5? Well, the compiler seems happy. So let's try to run this, see what happens. The reason this worked, because we actually said D is at this point is 0. So let's give that a value and see if that works again. D is 4 now. Let's see what happens. So 4 times 1.5 should be 6 by my math skills. Which still, wow, let's see if we can break this. My math skills is clearly better than my logic skills. That still fits into an integer. So we have a decimal times a decimal, but the result happens to fit into an integer. So what about we change this to 1.6? Now we got a problem here. That this has a problem. And let's see, we got one of these very lovely arrows that aren't really translated into proper AL. So we get a system implementation thing bubbling up. So overflow under conversion of Microsoft.dynamics.nav.runtime.decimal 18 value 6.4 to system.int32. So here we can see how Microsoft are actually implementing the things behind the scene. So when we say integer, this will actually become a int32, which is one of the .NET type. And we can see that decimal is not a native type in .NET, but it's a Microsoft Dynamics Runtime decimal 18. So this is Microsoft's own decimal type, and there is no conversion that will allow 6.4 to be converted from that to int32. But if the result of a decimal conversion is an integer, then as you saw, it worked, which is interesting because that is suddenly the properties of a dynamically typed language, but because we got it at runtime, we did not get this error at compile time. We got it at runtime because so this code will work in some cases. Okay, so let's try something else. because there are other interesting things here. So let's get rid of this. And then let's play with date for a second. So date is today. Date 2 could be date plus date. What? See, this is interesting. So we can say date plus date, but there is no plus operator between dates. But if I say date plus 7, this compiles. So let's actually put a message here and say result like this. Let's take a look. So now we said date plus 7. So and we got a date and 1 week later. So from that we can see that somehow +1 to a date gives you 1 day. But we also have a duration. So we could say, well, let's try something else. So what if we say duration equal date 2 minus date? And then let's just put duration here. See what happens. So the code compiled, there are no warnings, there are no message. So date minus another date equals a duration. That seems legit. And the result is, let me make sure that you guys can see this, 7 milliseconds. That seems, less than a week. Way less than a week, because apparently, since we got the number 7, what is happening here is that in reality, this could be translated so the result, and we might again actually both an integer and so we can always do d equal I, so we can always assign an integer to a decimal, because a decimal can always hold the value of an integer. But so in reality what happened is that date minus date outputs an integer, and a duration can be assigned to an integer. So what is happening in a line like this are two implicit type conversions, that the result of the date minus date turns into an integer, and then we use the integer to assign to duration. So there's a conversion of the integer to a duration, but we don't really see that, and we don't get any warning saying that, hey, what you're doing doesn't make any sense. So the result was this. Time is kind of the same thing where so let's play with time for a second. We got a second left, I think. Let's play with time for a second. So time equal time 2 equal time 1 plus, let's say 60,000. So let's see what we get from that. Well, since I use 60,000, those of you who can calculate, and I bet that's all of you, probably knows what we're getting here. So now we're getting, apparently it's late night here in British Columbia, which is why it's almost dark outside. So there's 1 minute between them. So the base unit in time is a millisecond. So we could do the one saying that, hey, duration equal time 2 minus time. Let's put this here and add duration to our thing. And now we get 1 minute, which is correct. But with duration, there is a very seamless. So duration is pretty much just an integer that gets formatted differently. What we could try to do, so see, what if we do time minus time 2? How does the duration then look? Is duration assigned or is it an unsigned value? Minus 1 minute, meaning that it's just an integer, just the way the everything else works. So in reality, it's mostly an integer that will format nicely. Here's the intro, because apparently I hit that key. Anyway, so there's lots you can do with types. The interesting thing here is that even though that AL is a strongly typed language, is also a conveniently typed language, meaning that type conversions happens. Some of them happens very seamless and we don't really think about it. Others we have to go in and do something. If we start working with like date time, we cannot really do. If we had a date equal date time, I think I created one called date time. That doesn't work. So now we have to use a function that will take the date part out of a date time and convert that to. So there is a function called dt to date, and now this one takes and if I'm able to do this, I call it datetime, not dt. TD. Well, anyway, so in that case, we need a explicit type conversion to go from this in order because we are losing information. We are truncating the date information here. We are truncating the time information. Wow, I think I better stop. You saw that this is past my bedtime anyway. So AL is both a very strict language, but it's also kind of relaxed typed language in some cases that you can convert if it's like with the same thing with the commit, that if it works, then it works. If not, we'll fail you in some cases at runtime, not at compile time. So it's always a good idea to be explicit about type conversions to make sure that your code, that the type conversion errors get caught at compile time instead of at runtime. But it's also in some cases very, very powerful that you do have compile or runtime conversion, and you can, like the weird JavaScript function we created, which was pointless, but there are certain cool things you can do with a dynamically typed language where you can reuse the same function to manage multiple types, seamless, and stuff like that. Anyway, that was, I guess, it's turned into computer science class. Not as much AL, but certainly some AL and applied computer science with AL. If you like that, let me know in the comments below if you would like more videos like this, or let me know in the comments below if you would like less videos like this. Anyway, and I suggest you subscribe and then go watch this one, because there's no type lecture in this one, I assure you. And I'll see you there. Take care. Bye.